Yesterday we talked about these numbers. First of all, what am I looking at? Okay, what am I looking at with these numbers? Zach M.
Yeah, what we did yesterday by counting by threes, and then we learned the 6 pattern, and then the 9 pattern. You just have to go with, then count by twos, like for 6. You just have to go 9. Then you get to your next 6-digit, like 12. Then 15, 18, like 6, 12, 18, 24.
Can you show me what you're talking about? Go ahead and put the pen on and take it off the highlighter. So, what's Zach saying? Because I was listening. He was saying we were talking about the patterns of threes.
And 9s.
And 9s exist also in this pattern.
Like 9s are.
Thomas.
There.
Thomas. There's just scoot over just slightly. Just
Let me say 24 plus 24 45. 48.
Okay, so wait a minute. 24 plus 24 equals 48.
Which is a multiple of 3, 5. 15.
Should 48 be up there then, Joey?
Yes.
Zach, can you also write 48 up there? Is that is the next multiple, right?
Yes, and also the white it's gonna go and also it's going to mean that they're right above each other.
That's more of a coincidence that they're right above each other though, aren't they?
Yeah.
Okay.
But if we wrote it to 27, then all the products would be right above each other.
Okay.
I remember, Thomas told us yesterday.
What did Thomas tell us?
I think I forgot what.
You need to draw it up there? Go ahead. Give Ruben the marker.
I think Thomas said there's 3 spaces between 1, 2, 3, and then 3 spaces between 18.
Can you explain more what you're talking about with spaces?
No,
What, Jamie?
Is Thomas.
Okay.
Thomas is since 3 times 3 is for 3 times 3, since it's 3 above 1, 2, and 3.
Okay.
And then there's 3 more spaces.
So 3 more spaces would be
18.
18
You could also do 12.
And 3 more spaces.
is 27. And 27 is a multiple of 3, but it's also a multiple of what other number? What other number? What do you think, Jude?
12 is also a multiple of 6.
Well, 12 is a multiple of 6, and I see that you had that highlighted. But what does that 27 that Ruben was talking about have to do with it? Grace?
Also, it's from 9. It's a multiple of 9.
It's a multiple of 9. Which is interesting because those first 3, 3, 6, and 9, are the first 3 multiples of 3.
Oh, I remember something else.
I remember.
If you guys want to add on, what can
Oh,
you
I like that.
Go ahead.
So what's also cool? Yeah.
You can change the color. Why don't you change the color? Matt?
No.
Okay.
It's fine. No. Like.
Oh, I found 2 things that's really weird.
If you add, let's say 3 plus 6. 3 plus 6, 9. 3 plus 9, that's 12. And it's 4 plus 2, that's 6. And 4 plus 8, it's 12. It's really cool.
So there exists some kind of relationship between a digit. Does anyone else want to?
I like that one.
Go ahead.
We also
I want
learned
to hear from you, okay? Because you
How-
had something very important yesterday to say.
how it's 3, 6, 9, 12. No, 3, 6, 9, 2, 5, 8, 1, 4, 7, 0. 3, 6, 9. There's
Yep, that's 2.
5, 8, 1.
And it keeps going
Then
on.
4, 7,
It's a
0.
pattern.
Oh, but we also learned at one point, there's 72 when we keep on going on. So it's not always this pattern, but then we learned 171 is a multiple of 3.
So we just picked a different digit. Okay, interesting.
Cooper, I'd like to add on.
If you want to add on, just go ahead and add on. Ruben, go ahead.
Also, what's...
You be next.
It's like... I think I forgot.
That's okay.
Can I add
Go ahead, Cooper.
So I'd like to point out to everyone.
Do you need to change the color, Cooper?
No, it's okay. Ugly noise. I know it makes a bad noise. Is this better?
That's fine. You're doing a great job.
Okay. So let's color in all numbers as yellow. These are all, the yellow is now digits of 3.
Okay, wait a minute. He's saying something really powerful, so I want to stop for a second. He's highlighting all of them as yellow, and he's saying they are all multiples of 3. That's really powerful because that is what we're counting by here, by 3s. Does that make sense what Cooper's saying?
Yeah.
Okay.
Oh, now we can't see the numbers.
Okay. We know kind of what place he's doing. If you circle it, go ahead.
Multiples of 6.
Okay, stop for a
All
second.
multiples of 6.
Because now, Zach, and because you did that, Zach was able to chime in something really powerful. Do you see what Cooper has done? And this, Thomas, is what you were relating to yesterday, and you said something about when Cooper first started doing just a multiple of 3, and then he did the 9s. You said, hey, look at the spaces between those numbers.
You can
Cooper then-
see the multiples of 9
I
because they have number.
Okay,
They have a line underneath the multiples of 9.
Wait, I'm not even done yet.
Hold on, Cooper's not done, but then Jamie, can you go ahead and add on?
Oh, what? I was gonna do that.
In purple?
27.
That's
27.
Thank you for helping out with it.
18.
No, 36.
36.
48.
You guys, I know. 45.
Hold on. Okay. So this we didn't extend the pattern far enough, but now look.
I circled
Okay.
out every single pattern there can be found in the 3's column. All are white because these are all digits of 3's. The 50, 51, 33, 39, 15, 21, and 3 are all left alone.
But if you went farther, there would be more.
And
Great math.
there are only 2 that have got all patterns. 36 and 18.
Okay, stop for a second right there, because what he's saying is really big. I want Jamie to have a chance. I want you to have a chance, and then we're going to move into another. And you can Stacy too. And then we need to. I want to exchange what you guys are thinking for a second. So Cooper, can you go ahead and let Jamie have a chance? I am that right now. You're making me happy. So go ahead, Jamie.
I don't really need.
Okay, that's fine. Here, I'll hold it. I'll hold it for a second.
So what I was saying yesterday, every pattern, it's like whatever.
Okay.
It's
Ruben,
like
not appropriate.
3, and that has 0. 3, 6, 9. The 3 patterns has 0 in between it, and the 9 pattern. The 6 pattern has 2 in between it.
Okay. You're doing a great job.
And then the 9 pattern has 3 in between it, and so on.
So what she's saying there's no spaces between the 3 patterns. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. There's no space between it. And Jamie's saying, and I see Helen shaking her head, like that makes sense. The 6 pattern has one number between it. And the 9's pattern, okay, has, if you look at where you circled, has not 2 digits, but 2 numbers between it. Okay? That's what Jamie's bringing up. Jude, what do you want to say?
Well, that's clear.
It's okay. So you're touching the board too. Go ahead.
What?
It's on pen.
No cutters.
You want a big pen? Or did you want a pen to write with? There you go. Okay. He's got it.
Always press itself.
So what do you mean by that?
I mean, like, 9 does itself in this 18.
Uh-huh.
And 18 does itself in 36.
So seeing another pattern here.
And you just keep going like that.
And that's kind of what Joey was saying when he was like, hey, 24 plus 24 is 48.
Can I add on?
Okay. Actually, we're going to give Stacy the last word on this, and then we're going to talk about something slightly different, okay?
Oh,
But what Jude was saying is he's saying, do you see on 9 plus 9 is 18? 18 plus 18 is 36.
Mm-hmm.
And what is very interesting about that is something Cooper was saying, and I apologize for talking right now because I know you're about to say something, is he's saying 3, 6, and 9 go into that number. 3, 6, and 9 go into that number. And that's what Cooper was saying, and Jude highlighted also. Interesting that they're both circled. They're both circled with all of them. I think that's very interesting that you picked up on what Cooper was talking about. Stacy, what were you going to add?
This is pretty interesting. It's actually a question. So, 15 is a multiple of 3 because 1 plus 5 equals 6.
Uh-huh.
And 6 is a multiple of 3.
Okay.
So, then we know that 150 is a multiple of 3 because 1 plus 5 plus 0 equals
Look what she's saying.
6. And 6 is a multiple of 3. So, my question is that could we fill in the 0 with the number? Let's just say that it was 1, 4, and 1. Could we do it like that and still make it a multiple of 3?
That's
Yeah,
a good question.
No.
No, wait.
Yes.
Listen to what Stacy's saying before you say no quickly. Listen to what Stacy just said. And Zach, I'm very proud that you moved back to a chair because you know you needed to sit up. And I appreciate that, Cooper. Make sure you're sitting up. So, Stacy's saying, hey, 1 plus 5 is that 6, and 6 is a multiple of 3. 6 is also a multiple of itself. I'm adding that in. Stacy didn't say that, but just, and then she's then saying, hey, 1 plus 5 plus 0 is 6. I know that's a multiple of 3, adding the digits together because of a rule that you guys proved, and that rule works. You guys generalize the pattern. Now look what Stacy's doing. She's dropping the digits' values. But is she changing anything if you were to add the digits? And that's what she's asking. She's asking you. She's asking this question to you. So you guys answer it.
I
Stacey,
think it's a
Stacey,
multiple.
look.
I was
Anyone
thinking
you want
no.
to pick?
Because
Hold on, Zach. Hold on, Max. She's gonna pick the ask because she's asking the question, so she can do the teaching right now, or you can do the teaching. She's asking the question.
I may not be correct,
That's okay.
but I think it might be because it's kind of, I think that's the rule,
Okay. What's the rule?
that the numbers, if you add them together, if it equals a multiple of 3, then it's a multiple.
And so if you add the digits 1, 4, and 1 together, and it comes out as 6, is that a multiple of 3?
yes. Yes, because 1 plus 1 is 2, and then 2 plus 2, well, 2 plus 4 is 6, and 6 is a multiple of 3.
And this is proven. This is proven. This rule is proven because you've tested it on these multiples of 3. Does that work?
Yeah.
Thomas, you want to add something? Because I've never heard from you today.
Because, like
Yes.
I was saying, 3 times 3 equals 9. So
Yes.
if you have 9 and you have 141, all you need to do is add on that 3 times 3, which is 9, and 141 plus 9 equals 150.
I
Whoa!